And then the thing walked away.
I was listening.
No. I don't know who said that, but you messed up.
It's under
Maybe so, and then you did that. But you didn't raise his hand or anything, so. I don't know. Like maybe you didn't want to show like anybody participating with the show. There's no shame there.
Watching this lesson so loud.
So we're gonna do T interval, so it's a confidence interval instead of a test. Instead of like making a claim and then rejecting it or not rejecting it. We're just looking to estimate. So like we'll be like we're pretty sure the mean ounces of the bottle of Coke is between like this and this. So same as the previous confidence intervals. But like the conditions and stuff are all kind of the same as yesterday, so this starts to hopefully get some more connections. So let's say that our sample came out to 19.9. Our standard deviation of our sample came out to 0.2. Our sample size was 50. So there's no claim, because it's an interval, it's not like we're trying to prove or disprove something, we're just trying to figure out, okay, given that, like, what do we think, like, the real mean is for the big population? Let's say 95% confidence interval. So that's like your intro, there's no HO and HA because it's not a test. And then we do our conditions, so shape, center, spread. Approximate normal y. N is greater than or equal to 30. For our center, all we really have to go off of is 19.9. There's no like population information, we just have our sample. Why is it 19.9? Because I totally do this randomly, right? Put in quotes. Randomness. And then for spread, this is basically justifying that things are independent. What's our, what are we looking at here? Same as yesterday, same as all the proportional ones too. 10% something, yes. 50 is less than or equal to 10% of like all Coke bottles. Conditions. And then we get to the math part. So yesterday we were looking for like, we said like T equals statistic minus parameter. We're looking for like a T-score. Now it's back to the statistic plus or minus the critical value times the standard deviation. We're not getting like a T equals this and putting it on the graph and shading and making a conclusion. We're just trying to get like, you told me 19.9 from our sample, so it's really, big picture is 19.9 plus or minus something, because we need some like margin of error. We're trying to figure out what that something is, so that's kind of what this part is. So statistic, so that's in words, then we do symbols, so x bar plus or minus, what's the critical value? not a number, but I'm looking for a letter. It's T, not Z, right? Why is it T instead of Z's? Because we're working with means. If we're working with proportions, it's Z. If we're working with means, it's T, so this is going to be T star. And then the standard deviation is the standard deviation of our sample divided by the square root of it. So that's words, and that's symbols, and then we put in numbers. So our x bar is 19.9, right? T star, so we found this yesterday, so grab your calculator if you don't have it out. Started class yesterday, I gave you like that printed sheet, and we found like T sub 10, T sub 50, T. So remember it's inverse T. So you do distributions, nope, that's not it. It's stat, and then go to tests, that's not it, it's too early in the morning. It is distributions. Second distributions, I was like stuff ahead of myself. Inverse T. 1.95 divided by 2, because that's at 95%. What's the degrees of freedom? 49, because the sample size is 50, and you always subtract 1. And then if you don't have the prompts, you just gotta type it in, so you just like type it like this instead of the prompts. Does that happen? Does everybody not have the prompts, or is it always? You don't. T it out usually thinks for a second. So I get it's basically 2. When you write that, I'm still going to leave room for the standard deviation, but off to the side, I'm going to write degrees of freedom equals 49. I'm telling the person grading it, I know what I'm doing. I know I use degrees of freedom. I know what it is. And then we fill in the standard deviation from our sample, which was 0.2. Divided by the square root of our sample size. So that's square root of 50. So this is your actual n. So you put the size here, and then you put the degrees of freedom in the calculator, which is 1 less. And then I'm not figuring all that out. The calculator did it for me. But questions on what I'm putting where, or why, anything there? Alright, so go to your calculator. Now you go stats tests. T interval. So that's number 8. Then we're going to put in all our stuff. So x bar was 19.9. Standard deviation was 0.2. And n was 50. I wanted a 95%. Well, basically just telling the calculator all the stuff I wrote down in my numbers there. Hit enter. Am I good to hit enter? I don't know if anyone's like still looking at it. Should give you the interval. So I get 19.84 to 19.96. Are you still looking at this? Anybody? So there was really no claim in this, and there's not a claim. It doesn't have to be a claim in a confidence interval. But if they claimed 20, what would we say about their claim of 20? We would reject it, it's BS, because 20 is not inside the interval. What if they claimed 19.9? Fail to reject or accept? Fail to reject. It didn't prove it's true, it's not obviously wrong enough that we can say it's not true. And then you just write the conclusion. So we are 95% confident that mu. I was about to write the context again, but then remember you don't have to, because mu, when you reference it, already contains your context. It's between 19.84 and 19.95. Questions on there anywhere? Alright, I want to do a template, but I want to show you something else first. Go to your list, go stat, and then edit, and then clear out anything that's in there. Remember, you can go to the top and hit clear and then enter. Don't hit delete. Delete destroys like the whole column. Clear that out, and let's just say instead of like us having what the 19.9, like they told us the sample mean, they told us standard deviation. Let's say they didn't. Let's say I just had a list of numbers. I go measure all these ounces of Coke and I get like, so type in with me, 19.9, 20, 19.9, 19.85, 20.5, 20. That's fine. I'm just trying to make a point. I'm just show you something. I don't need a huge sample size here. So we can do the test from there, is what I want to show you. You could like go through and if you want to calculate the mean and standard deviation of that, welcome to, but that's not the easiest way to do it. So go to stat, tests, and t-interval again. Then hit enter. But instead of doing the stats, I'm going to go to data. I'll be like, look, you have the list of data. You figured this crap out. I don't want to. The data is in my L1. Frequency will just always stay as 1. And it's just going to go to my L1, figure out the mean, figure out the standard deviation, and do all the stuff for it. So it saves you a step. If you have the list of numbers, you can type it in. If it's like 50 numbers, you're probably going to want to have like the average and stuff. But if it's short, you can just type it in. And it'll give you a confidence interval through that also. And you can do that for the t-test too. So if you have data, you can like work it easier in the calculator. Alright, let's do a template. This is a t-interval. It is one sample. It is for means. And this is our template. It's BRT, right? Alright. So you start off by identifying what you're working with. So mu is the true population mean of whatever your context is. And then I think it's helpful at the top to write down what's your X bar, what's the standard deviation of your X bar, what's your ed, what is that? Seriously? Was it, I mean, actually, like,
That's what I was thinking.
and then probably the confidence level too. You're trying to match the sound. And then you'll have like a blank percent confidence level. So they'll tell you 90, 95, 99, whatever. That's like your intro. Where with the test, where the intro has like your HO and HA, because the test is more like, here's a claim, do you believe it, yes or no? Where this is not that, it's just like, what do we kind of think the general estimate is? So then you got your conditions, so shape, center, spread. Remember for shape, you got 3 things. For means, you have 3 things. It could be any one of these. Easiest and what you're hoping for is n is greater than or equal to 30. If you don't see that, if it's n is like 20 or something, then you're really hoping it says the population is normal. Like if I had told you the distribution of ounces of Coke is normally distributed or something, you're really hoping for one of those, because if you don't have one of those two, center. Center is X bar. That's the best we have. That's the only really thing really the only thing we do have. Because you need randomness for SRS. Then what? I feel like I should make you guys do this, but what comes next? You can help me through it though. Spread. And then also the spread is showing independence. Yes. And what's out? 10% thingy, so small n, like our sample, is less than 10% of the population, so capital N. Then I'm gonna put my, kind of my formula, it's not really a formula because there's no equal sign, but like my thing, in words, symbols, and then numbers. So statistic, what would you call that? Expression. Critical statistic plus or minus critical value times standard deviation. So we got our estimate, but we need a margin of error. We need to be able to say it's, well, give us a little wiggle room on each side. So this is our wiggle room. And then we put in the symbols. So statistic is X bar. Critical value is T star. And you might want to put like, you don't have to show this on your, like when you're doing one, but if you want to go off to the side, like remind yourself, hey, that means inverse T, 1.xx divided by 2, comma degrees of freedom. Squeeze it in there. But just to like make a note to yourself if you want to remember how to find the T star. And then I'm going to put off to the side degrees of freedom equals to let the grader know what degrees of freedom I used when I found my T star. That's a new thing, like there was no need for that on the proportions at all, just for means. And then the standard deviation is our sample standard deviation divided by the square root of it. Which we have all that stuff from above, like that's why we put this stuff up here. And then you plug in numbers, so like I could put a bunch of number signs there, but it's just easy to say plug in numbers. So again, you're showing the grader, words, symbols, numbers. And then you go to the calculator, so then you go tests, t-interval, because it's stat, and then tests, and then t-interval. And you'll get your, you get your answer, your confidence interval. And then you make your conclusion. How do I start the conclusion? And we are whatever percent confident, so whatever they gave us. So you could say that the true population mean is between whatever and whatever. That's like kind of some additional context, which is definitely not bad. But you could also shortcut it and say that mu is between whatever, because you already at the top said, hey, mu is the true population mean. So you can use that and kind of like plug it in there. Between whatever and whatever. Questions on this at all? Okay. I want you to do one, so I don't have to need another sheet of paper. This is the annoying one, because I'm not telling you n is greater than or equal to 30, and I'm not telling you the population is normal, so I'll just show you a little bit how to do the conditions part for shape, but that's the context of the problem, and then I'm just going to give you some numbers. I said 10, so let's say 5,000, 6,000, let's just make it easy. 7,000, 8,000, 7,000, 6,000, 5,000, 4,000, 3,000, 4,000. I think that's 10. That's 10. So when you do the shape part, so for shape, you don't have the two things that we really would prefer we had. So you have to make a little dot plot. It does not have to be fancy. Look how casual I am. Just put K instead of 1,000. It's crazy. And then you just put little dots there. So 5, 6, 7. 8. 6, 5, 4. And then you just go, no outliers or skew. And then you can say approximately normal. So it doesn't go up a ton. It does happen where you're like cramped and didn't give me enough information. I actually have to make this dot plot. Don't put a lot of time or effort into the dot plot. They're not looking to see if it's labeled. They're not looking to see if it's like pretty. They just want to know that you know you're supposed to check it. And then you can say approximately normal. So go ahead and finish the problem. Just keep that part in mind. Is it big enough? I'm curious to see the numbers. Okay. Don't forget a title. We got better, a lot better last test, but there were still a couple people that forgot a title. Oh, I took an SRS, by the way. I just didn't oh, that's not right. Just gonna say that. So at the top, hold on. What I would do is run the test. Like go to your calculator first, type in the numbers and do it, and it'll tell you X bar and standard deviation. Like when you force it to do the interval, the answer is the interval, but below it says X bar and the standard deviation. So you like do it first, and then kind of like backfill your paper. Does that make sense what I'm saying? So this is from the data, right? So you just put them in your L1. Make sure you change your confidence level because I switched it to 99 on this one. I'll put this back in a second. But this is what I wanted to show you. I'm I'll put it back in a second. When I run because at the top, on the template, I just told you to put like X bar and N and the standard deviation. Then I give you a list of numbers where you don't have all that stuff. But if you run the T interval, it tops out with that. So then you can like write those down at the top. I'm gonna pull that down in a minute and put up like my work. So if you don't have those numbers, make sure you grab them. So here's my work. So check yours out. I was a little lazy. I just said C4 for the shape. But I did it. If you got it, you're all good. I got nothing else. Tomorrow we're gonna, maybe you want to start thinking about it. Tomorrow you're gonna do a survey. So you're gonna go ask students in other classes questions and then do a confidence interval and a test. The questions you ask the students should have a number for an answer where you can like average them together because we're working with means. So you want to find them. You want to ask them a question where you can try to find the average. So if you want to start thinking of questions. I got nothing else for you right now.
So weird. I have so many pieces.
Because there's multiple boards.
So nice. So now I have no chicken tacos. Let me grab that out.
And this?
Oh no, there's something else.
No.
I think so. I think it's pizza. I think so. Order right.
Yep.
I don't understand.
DF. This one.
Degrees of freedom, and that is the sample size minus 1.
Okay, so it's just.
Which is that minus 1. Yeah. Every time.
All you didn't need is signature. I'm 18. That's why I'm like, I don't know what I need to. That's why I'm done asking my parents.
I seriously don't think that I need this.
For what?
It's for choir things.
You can't be singing without parent permission, man.
I know.
That is
They don't care.
terrifying.
They don't know where I'm going half the time. I told them I'm going to Canton later tonight. They were just like, okay.
I can't believe that.
They don't know where I am.
Powers just go.
What did you want them to say?
No, but they just like didn't ask what I was doing at all. They were just like,
She's like, whatever.